Hi class, I just want to go over some questions on the practice exam for chapter 6 and 7. Specifically, I want to go over number 27. So as a few people had asked me, how do you solve an inequality when it's irrational? So I'm going to do a quick lecture on that. So how to solve rational inequalities. The first step is let's pretend it's an equation and solve for x. So pretending that this is an equation and solving for x, how do we do that? So I'm going to rewrite this rational. And instead of saying less than or equal to 0, I'm going to say it's equal to 0 because I'm going to pretend it's an equation for now. This is just for step 1. Later on, we'll go back to it being less than or equal to. The reason why we set it equal to 0 is we want to solve for x right now. What would make this equation equal to 0? So what it means to solve for x in this problem is, number 1, what makes the function equal to 0? So that's part 1. So part 1 here, what makes this equation equal to 0 is, in other words, when does the numerator equal to 0? When the numerator is 0, you'll always get a 0 as an answer. So what makes a function equal to 0? When the numerator equals to 0. So I'm going to set the numerator equal to 0 and solve for x. So here I have negative x plus 6 is equal to 0. What makes the numerator equal to 0? So I'm going to subtract 6 from both sides. So in other words, x is equal to positive 6. So if you plug 6 in here, you'll get 0 in the numerator, which will make the equation equal to 0. So that's one of the x's. Now, the other x is when you ask yourself the question, what makes the function undefined? Well, undefined means when the denominator is equal to 0. If you try to plug into your calculator 5 divided by 0 or any number divided by 0, you're going to get an error. That means it's undefined. So when does the denominator equal to 0? So in this case, when does x plus 1 equal to 0? Well, that occurs when x is equal to negative 1. All right, so here in step 1, we found that x equals to 6 and x equals negative 1 are numbers that either make the equation equal to 0 or undefined. And these are what we call boundary points. If any of you guys take calculus in the future, this is going to be really important because these are similar steps to what we're going to be doing in calculus as well. Boundary points. All right, so step 2 now that we have step 1, step 2 is to plot your boundary points on a number line. And remember to do it in order from lowest to highest. So here's a number line. And I'm going to plug in negative 1 and 6. So remember to do it in order. So the smallest number out of the two is negative 1, and the 6 is on the right. So again, write it in order. Okay, so what I'm going to do is I'm going to test points outside of negative 1 and outside of 6 to see if I plug in values into this function, will I get a positive or a negative answer? And the reason why I'm doing that is this question is asking me what values will make this function, and I'll call this function f of x, what values will make this function less than or equal to 0? Less than or equal to 0 means what negative answers. So what x's will give me negative answers for this function, right? So I want to see where all the negatives are. What will cause this to be negative? So I know that at negative 1 and 6, I know it's at negative 1 and 6, the function will either be equal to 0 or undefined. So what happens around those points? So that's what we're going to do. Test points around the boundary points. And you want to ask yourself, do you get a positive number or do you get a negative number? So let's go ahead and try that out. I want another color pen. I'll just use black for now. So I'm going to plug in a number less than negative 1. Say we pick the number negative 2. So if I let x, let me just do it. If I let x equals to negative 2 and I plug it into this function, so I'm going to call this function here. If I plug it into this function, what values do I get? So if I plug negative 2 in here, I get negative 2 plus 6 over negative 2 plus 1. If I plug this in, I end up getting a positive 4 over a negative 1. In other words, I get a negative answer. So again, I plug negative 2 into the function, and I realize I get a negative answer. So here, to the left of -1, when I plug -2 in, I get a negative answer. And I guarantee you, if you plug -3, -4, -5, anything to the left, you'll always get a negative answer. All right, so let's pick a number between -1 and 6. So you can plug 0, 1, 2, 3, 4, 5. So work smarter, not harder. What's an easy number to pick? I like the number 0. So I'm going to let x equal to 0, and I'm going to test this 0 and plug it back into the function. When I plug it back in there, I get -0 plus 6 over 0 plus 1. What kind of answer do I get? Do I get a positive or negative? I get 6 over 1, which is a positive answer. So here, between -1 and 6, we get a positive answer. Again, even if you plugged in the number 4 or 5, you'll still get a positive answer. Go ahead and try that if you want to test that. Lastly, I'm going to check what's a number bigger than 6. So I'm going to say let x equal to 7. Again, you could pick 8, 9, 10, any number. So if I plug 7 in here, I end up getting -7 plus 6 all over 7 plus 1, which will give me a -1 over 8, which in other words is a negative number. So after 6, after that boundary point, my test values will give me a negative. All right, so what does this mean? This means that any number that you plug to the left of -1 will always be negative. Any number that you plug in between here will always be positive. Any number after 6 will always be negative. If you plug it into this function, you'll get these types of answers. So the last step now is to answer the question. The question is asking me what values will make this function less than or equal to 0. In other words, what values will make this function negative? Will make this function negative here. So I want my negatives, right? So the answer is that these values here, anything from -1 to -infinity, anything from 6 to positive infinity will give me negative answers. And that's what I want. I want values that would make this function negative. Okay? So that's those what the arrows stand for. Now, we also want to know when it's less than or equal to 0. So I want to know at -1 and 6, do I do an open circle or a closed circle? So they're asking me, when is this function less than or equal to 0? Well, if I plug -1 into this function, guess what? If I plug -1 in here, I'm going to get undefined because you can't have a 0 in the denominator. So therefore, I'm going to do an open circle on -1, which means the answer does not include -1. If I plug 6 into this equation or into this function, I'm going to have -6 plus 6. I'm going to get a 0 in the numerator, which means my answer will be 0. Can I have a 0 in this problem? I sure can. It's less than or equal to 0. So since it could equal to 0, my 6 is going to be a solid